So my name is Megan. I work at Rabbit, doing mainly back-end web development with Ruby on Rails. So today I'm going to be talking to you about debugging. So what is debugging? It's the act of finding bugs or exceptions or defects in code and ripping them out, fixing them, however you want to describe it. It was popularized but not invented as a term by Grace Hopper when she found a literal bug in a machine. There was a moth in one of the mainframes at the military facility that she worked that was causing all sorts of glitches in the machine, and they enshrined this moth as a bug that they found. If you don't know who Grace Hopper is, she was possibly the first person to ever write a compiler, and also was the inventor of COBOL, for better or worse. So yeah, she's a pretty amazing figure in computer science history.
General in the Navy too.
Yeah, yes. No, Admiral. Admiral Grace Hopper. Yeah. So very impressive woman. So this may be obvious, but why do we need to debug? So machines do exactly what we tell them. There's no room for ambiguity. And at the end of the day, we're not perfect. We're not infallible. Even if we are perfect, as some of us are, some other person on your team or some third-party developer or your users, as they quite often are not perfect. So something is inevitably going to go wrong, and someone is going to be breathing down your neck to fix it. Whether that's the voice in your head or someone putting a bug on the bug tracker is, yeah. So what happens when we see this in our Rails app? Or maybe this from our trying to use our printer in Windows XP apparently. Or this, the dreaded blue screen. There's a few techniques, tools, and concepts that we can use to figure out what exactly went wrong, where it went wrong, and how we can fix it. So I'm going to talk about some of those, mostly focusing on Ruby and Rails, because it's well-railed after all. So at the simplest, you've got this thing called print debugging, where basically you don't have any better tools. You've got a console that you can output some text to, and you know something's broken. So you start putting little print statements or puts statements everywhere in your code to try and figure out where you are and where exactly it's breaking. These days it's only generally used in embedded systems where it's hard to get any better tools in there. So things like your microwave or refrigerator or whatever else they're putting chips into these days, your car. Because if that goes wrong, yeah, there's that happen. So it might look something like this. So we've just got a put statement here saying, you know, giving us a bit of context, we're about to do something bad, and this function doesn't actually exist. So we're never actually going to reach this next line. We're never going to get that output. So when it does break, down the bottom here, as you can see, it's printed that first line out, and it's exploded. So we know it never got past that. So evolving from that, because that's about as primitive as you can get, we have what are called stack traces. So instead of relying on trying to put a unique print or put statement everywhere in your code and doubling your lines of code and generally being a bad idea, you can use these things called stack traces, which tell you exactly where in the code that things broke. Gives you your line number, your function name, file name, what have you. Even like a full list of the functions that called it and where they are. So it provides a lot more context to us and allows us to know exactly why things blew up. So this is an example from Rails, from some code I was working on today for FleshMe, if you've heard of FleshMe. So as you can see here, it's actually blown up in the internal Rails gems in Action Pack. You can see that by the prefix there, Action Pack version 4.0.5, and there's its file that is blown up in the line number and the function name. We have to go down a bit, step back up the tree as such, to find where in our code things have actually blown up. So here you can see an app helpers campaigns helper, line 36, in the function name campaign actions, things went slightly awry. It provided a bad parameter to a library function and things did not go very well. Continuing on from that, there's the concept of debug logs. So we're generally not monitoring our console output all the time to catch when things are blowing up. So we can come along later and have a look through our debug logs, which is collecting all these all the console output into the file for us. It's where you often find where the stack traces are. And in Rails projects, it can be found in the log folder in your project folder. You probably haven't generally looked at it, but in there you'll find things like development.log and test.log, and if you're on a production system, production.log. And as you expect, that's the development output and the test output and that sort of thing. Then we move on to interactive consoles. So this is a common feature with dynamic languages like Python, Ruby, Node.js, Perl, that sort of thing. Dynamic languages are languages where you're not actually compiling them. There isn't a step where you have to process the code to turn it into machine language. They're just compiled as they run. So this means you can just, the computer can run the code as you type it, making interactive consoles more easily made. So you can do things like run a statement at a time and change the parameters around, see what works, see what doesn't, see why exactly passing null to that function blows it up. And just as a good tool for learning in general. You've probably encountered it in Ruby as IRB, but Pry is a much better alternative, in my opinion, which is an alternative provided through a gem. IRB is built into Ruby. And you most often encounter it through Rails by running Rails console. So that will give you an IRB with the context of your Rails application. And we move on to the magic of debuggers, which are, as implied by the name, one of the most important tools in your toolset. They allow us to set what are called breakpoints in code. So this can either be a statement, or if you're using an IDE like Visual Studio for .NET, it can be actually physically marking a line, as that's where you want the code to break. So that will, as the computer is running the code, when it hits that, it will pause the program and will drop you into a interactive console, as we saw earlier. We can then have a look at the state of the variables in the function. We can have a look at the overall state of the program. we can check whether things are in the appropriate state as they should be, things are going as they should. And we can also run more code to see if the next steps will actually succeed or not. In Ruby and Rails, it's provided by the debugger gem in Ruby versions less than 2. Unfortunately, in later versions, it's quite broken and they haven't got around to fixing it yet. So there's an alternative called Bybug, which is a different gem. And it also, of course, has to use different keywords for its debugger statements. Oh, I was going to do a demo here. If it's getting, here we are. Okay, so if we have a look in this example code here, which I'll blow up for you. Okay. Can anyone remember how to zoom in Variable Plus? Yeah, I tried that.
It works. I'm going to do it a few times.
Yeah, right, yeah.
So, as you can see here, this is just a Rails scaffold. So this here is our debugger statement. Now this could be debugger if you're using the debugger gem, or Bybug if you're using Bybug. That depends. This is using something called pry Bybug, which is integrating pry, the alternative to IRB, with Bybug. So when it hits this, it will drop into pry rather than into IRB. So if we see this in action, if I can, maybe it helps if I look at this screen. And navigate to the URL where it's going to pause. So as you can see, it's just spinning there because the program has stopped running. It's paused. And if we go into our terminal where it's running, and again, I'll blow it up for you. On the bottom here, can you all see that?
Mm-hmm. Do you want to drag it to the blue side at the top?
Straight bottom up.
Good idea. You can see here it's stopped at that particular line where we've set a breakpoint. So here we can actually see the state of our variables in the foos. We've got foo1 and foo2. And from here we can actually step to the next line. So either step or S. And we've moved on to the next line. And if we step again, we actually move outside the function because it's finished, and it moves up to what we called it. But we can still have a look at, well maybe not there, but you would have seen this state of foo change. So now we can continue, and that continues on, and the page loads.
You still have turbo links in there.
Yeah. Yeah. So yeah, it's a really powerful tool, but pretty simple in concept. So now there's some less common and some Ruby or Rails specific tools as opposed to general concepts. And this is where I get a bit fangirlish and talk about this awesome tool called Wellrailed. So when we deploy our apps to our production system, quite often what happens is all the debug statements, all the verbose output gets turned off, and things like, while error logs may still be outputted, it's a bit more work to get at them. You can't just, when you go to a broken page, it will just say an error occurred and you won't get any other context. The other alternative is that we might be working with a client that doesn't give us access to the machine, they control access to it, and so we can't get access to the logs. So this is where awesome tools like Raygun or Airbrake is an alternative. They allow us to keep track of errors that occur in production. So what happens is an error occurs and it sends off a little bit of JSON to Raygun servers, and they process that and turn it into pretty graphs and send out all sorts of alerts to you. And it includes the stack traces and also the program state, so that can tell you who the current user who's experiencing the problem, the web browser they're using, the request parameters they provided, all sorts of useful information. Yeah, you can check them out at raygun.io. A very useful gem that I use is one called Better Errors. So the default Rails error page when you're in a development environment isn't actually that useful. Better Errors provides a better error page in your development environment. So it gives you your, what it calls frames here. So this is each thing in your stack trace, each function. So you can navigate between those and see what particular code's there, and it will actually give you the context there. So in your right-hand window here, you can use that like you would prior IRB. Down the bottom here, you can vaguely see it gives you the request parameters, the session variables, all sorts of stuff. So quite handy. And just to give you some things to think about in terms of like more advanced concepts that are kind of outside the scope of this. What happens when the code is not running on a machine? How do we debug that? It is possible, but it's more complicated. And looking at remote debugging probably will help you out. How do we debug code that isn't our own? So what if they're using different tools? What if they're using a different language? Can we still interop with that? And how do we debug when the code isn't available? It is certainly possible, but very much not easy, extremely technical, and requires a lot of knowledge about how computers work internally. And this is the difficulty of that. Is why open source is so important. It's something the Rails community kind of takes for granted a bit, but not something we think about necessarily. So yeah, that's that.